Welcome to Kids Academy.
Hello, welcome back. I am so excited today because we get to do a new worksheet, and the name of our worksheet is called Practice Fractions with Cinderella. I love Cinderella. How about you? Let's go ahead and look at our directions. Our directions say trace on the dotted line that divides each group of items into half. Tick the box next to the group that does not split in half evenly, okay? So we've got a couple of things that we're gonna do here. The first one that we're going to do is we are going to look at each one of the rows of items, and we're going to just try to divide it into half so there's equal parts on both sides. So let's take a look. What we need to do first is count these up. We've got Cinderella's glass slippers, right? So let's go ahead and count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you might already know what half of 10 is, but sometimes you don't. So one way that you can figure out half of 10 is to draw over to the side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to see what is the half point. So what you can do is you can cross off on both sides. So here and here, here and here, here and here, here and here, and then we've got our 2 right here. So the line we're going to draw in between when we get to the 2 middle ones, and we're going to count up how many is on this side. So we've got 1, 2, 3, 4, 5. So that should be 5 on the other side if we divided it up evenly. Let's check. 1, 2, 3, 4, 5. That's even, that's equal, or that's the same number. It divided up evenly. And that 5 plus 5 equals 10. 5 is half of 10, okay? So let's come over here and let's find the halfway point for our slippers here. We've got 1, 2, 3, 4, 5. So this dotted line right here is the half point, okay? And it says here the other direction was tick the box next to the group that does not split in half evenly. This one does split in half evenly, so we're not going to tick the box on this one. Let's go down to the next one. The next one looks like we've got our little mice with some cheese, okay? Do you remember that in the story, the little mice? Let's go ahead and count these up and see how many there are. There is 1, 2, 3, 4, 5, 6, 7. So we've got 7 total. Let's go over here and draw out our picture. We've got 1, 2, 3, 4, 5, 6, 7. And do you remember what I told you that we're going to do? We're going to cross off on both sides, and we get to 2 in the middle. We'll know which is the half point, okay? So let's look. We're going to cross off 1 here, and 1 here, 1 here, and then 1 here, 1 here, and then 1 here, and oh, well, this is different, isn't it? There's not 2 here. We can't divide it in half, can we? So that lets me know that this can't be divided in half equally because I've got 3 here and I've got 3 here, but then I've got 1 extra one, and I can't divide that one in half. Now, actually, you probably can't, but those are other kinds of fractions. That doesn't divide evenly. So on this one, remember the last direction that says tick the box next to the group that does not split in half equally? This one, we're actually going to come over here and we're going to tick that box because unfortunately that one we can't divide up evenly, right? Because 7 is not an even number. Do you remember that with even and odd? 7 is an odd number. That means that there's one odd one out. So that one's not even, okay? Let's go down to the next one. We've got our magic wands here, okay? Let's count up our wands. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our total number is 12, and you might know what the answer is, but let's come over to the side and draw out 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So remember what I said we're going to do. We're going to tick off on both sides, here, and then here, here, and then here, here, and then here, here, and here, here, and here, and then we've got 2, so we know it's even. And then we've got 1 here and 1 here, so we're going to put that line right in the middle, and we're going to count up how much that is. That's 1, 2, 3, 4, 5, 6. If we did it correctly and we divided it evenly, then the other side will have 6. So let's check. 1, 2, 3, 4, 5, 6. We did it. We've got 6 and 6. 6 plus 6 equals 12, which was our total amount. So let's see if we can find that halfway point after 6. We've got 1, 2, 3, 4, 5, 6. So there's that dotted line that divides it in half. Okay, nice job. Now let's go down to the next one. We're about halfway done. We've got that clock that strikes midnight. Do you remember that in the story? That was fun. Okay, so let's look. How many do we have all together? 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 total. Let's draw over to the side. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to tick them off on both sides, remember? And then we should have 2 in the middle. So here's 1, and here's 1, here's 1, and here's 1, here's 1, and here's 1. We've got 2 in the middle, so we did it right. Here's 1, and here's 1, and we're going to put that dividing line right down the middle. How many do we have on each side? We've got 1, 2, 3, 4. So there's 4 here. 1, 2, 3, 4. 4 on this side. And 4 plus 4 equals 8. That was our total number of clocks. So let's find the halfway point here. We've got 1, 2, 3, 4. So our halfway point is boop, right there. Okay, great job. Okay, now we are almost done. We've got her pretty dress. I love that dress in that story. Let's look and see how many there is. There's 1, 2, 3, 4. There are 4 dresses. So let's come over here and draw that out. 1, 2, 3, 4. And then we're going to tick off on both sides. So here, and then here, here, and then here. And remember, those were our last 2, so we're going to divide that in half. So on each side, there is 2. 1, 2. 2 plus 2 is 4. That was our total amount. So we're going to divide that. 1, 2. So that line is right after the 2. Okay. And we've got that divided evenly. And this one's pretty easy to see. You can see that that's divided up evenly, right? Okay, one last one here. Great job. We've got our magic pumpkins, don't we? Let's count how many there are. 1, 2, 3, 4, 5, 6. So we've got 6 total. We're going to draw that out. 1, 2, 3, 4, 5, 6. We're going to take them off on each side. So 1 here, and then 1 here, 1 here, and then 1 here. There's our 2. We're going to tick those off, 1 here and 1 here, but we're going to put a line right down the middle. Count up each side. We've got 1, 2, 3 on that side, 1, 2, 3 on that side. 3 plus 3 is 6, which is our total amount. So let's find that line right after our 3. 1, 2, 3. There's that line right there. We're going to trace it, and we are done. Awesome job. Bye-bye, friends.
Hello, welcome back. Today we have a new worksheet. The name of our worksheet is called Guess the Number. And what we're going to be doing is we're going to be using several different equations, but they're going to help us find a couple of different missing numbers. So what we're going to do here is we're going to take a look at our directions, and it says check the correct rule for each function machine and use it to find the missing number. Check the numbers that is missing. So we're going to start with this. We've got one column over here says input and one column says output. And what this means is on the input column, that's the number that we start with, as if this were a machine and we put in the number 8. Then we have to find the rule, which could be adding a number or subtracting a number, and then that will give us an output number or the end number of our equation. So our first equation is 8 something equals 7. So we have to figure out, is it 8 plus 2 equals 7, 8 minus 2 equals 7, or 8 minus 1 equals 7? Well, I see at the end of my equation that there is a 7, which is smaller than the number 8. So that tells me that we're going to have to subtract in this equation. So I know it's not going to be plus 2, but it could be minus 2. So if you're not sure, go ahead and plug it in and see if it works. So 8 minus 2 equals 7. Is that the correct answer? Let's check on our fingers really quick. If I have 8 and I take away 1, 2, that gives me 6. So that is not correct. I can see that that's not going to work. So I'm actually going to try the last one, which is minus 1. So I'm going to plug that in. 8 minus 1 equals 7. And that is correct. If you're not sure, you can always draw it out. 1, 2, 3, 4, 5, 6, 7, 8 minus 1, okay, equals 1, 2, 3, 4, 5, 6, 7. The answer is 7. So this is the correct answer, -1, or that's the correct rule. So I'm going to put a check right here because I just checked it to make sure it was correct. Down here, I need to follow that same rule to give me the first number, okay? So the rule is -1, okay? But I don't know what the first number is. So something minus 1 equals 14, okay? Now this is tricky. I'm not sure what the answer is. Something minus 1 equals 14. But here, for this, we're going to use something called an associative property. An associative property is basically telling us that we have a number family. We have 3 numbers that always go together. And no matter how we mix them up with an addition problem or a subtraction problem, they're always going to go together. So I know that since this is a subtraction problem, the number that we don't know is the biggest number. So something minus 1 equals 14. Okay, so I know the number 1, I know the number 14, but I don't know the last number. So actually what I need to do is I need to change this problem around or make it in a different way. And this time I want to make the number that I don't know on the end. So I'm actually going to turn this into an addition problem. So 1 plus 14, those are the 2 numbers that I do know, equals my mysterious number. And if you add these up, 14, 15 is going to be the answer here, okay? So let's see if we can find that over on our little robots here. I've got 15, 12, and 13, and we just figured out using the associative property that 15 is the correct answer here. So I'm going to actually just put a check right here. I don't need to actually write it in, okay? So let's go on to the next one, okay? And we're going to follow the rules again. So I've got 2 and then something, whatever the rule is, equals 12. And whatever this something is should make sense in each one of these different equations. And I'm just going to do the first one here. 2 and then something equals 12. So I know since 12 is bigger that I'm going to need to add here. So it's not going to be a minus. So it's either plus 8 or plus 10. 2 plus 8 equals 12 or 2 plus 10 equals 12. Well, this one should be pretty easy if you think about it. It's going to be plus 10. 2 plus 10 equals 12. And if you couldn't just figure that out in your head, you can always write it out. 10, 11, 12. So 10 plus 2 equals 12. Okay? That should work in our next problem here too, that plus 10. So let's just go ahead and make sure that works. So 8 plus 10 equals, and our output on the next one is 18, right? So let's try, let's have 10 and then add 8. 1, 2, 3, 4, 5, 6, 7, 8. And what does that equal? 10 plus 8 is 18. So we know that plus 10 is our rule here. So I'm going to come over here and I'm going to put a check. So I know now for the next one that something plus 10, okay, equals 20, all right? But I have to change it around using the associative property to make this so that that mysterious number is on the end. So this time I'm going to have this number over here, and now I'm going to turn it into a subtraction problem. So can I take 10 minus 20? No, I can't, because 20 is the bigger number. So I'm going to start with 20 first, and I'm going to take 20 minus 10 equals what? And I'm going to draw these out in columns. So I've got one column and two columns for 20. And then I'm going to subtract 10, which leaves me with how much? It leaves me with 10, right? So I know that the answer is 10 on that one. I'm going to put a check right over here, okay? Now let's go on to the last one. The last one in our number machine, we start with, or the input is 12. We need to do something for it to equal the output, which is 8. So I think I'm going to have to subtract, since 12 is the bigger number here. So I can either subtract 4 or subtract 3. What do you think? Let's try 4 and see if that works. So 12 minus 4 equals 8. Well, let's draw it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now let's subtract 4. 2, 3, 4. Does that give us 8? 1, 2, 3, 4, 5, 6, 7, 8. It does. So I know that minus 4 is going to be my rule. But let's double check. Let's look down here and check if it works in that one too, because if it's a rule, it'll work every time. So we'll do 10 minus 4 should equal 6. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus 4, 1, 2, 3, 4 gives us 1, 2, 3, 4, 5, 6. That's correct. So minus 4 is our rule. So now I know that 14 is the number that I start with, because that's the input. Now I'm going to subtract 4, which is my rule, and then I need to find the answer. And I can actually just find the answer. I don't have to turn this into anything different or use a different associative property to find this answer, because my unknown number is at the end. So I'm just going to take 14 minus 4. So I'm going to have a column of 10 110s, and then 1, 2, 3, 4 units of 1 minus 4 units, 1, 2, 3, 4, and that leaves me with 10, right? That should be my answer. Do I see it down here? I do. My first robot right here is 10, so that's the correct answer. So that's how we solved for our missing number today, using the different equations and the rule to help us find that missing number. And we used the associative property today to help us come up with some of these answers. So great job today. I'll see you guys again next time. Bye-bye.
Hello, welcome back. Today we have a new worksheet, and the name of our worksheet is called Let's Regroup to Add. And I'm going to be teaching you today about a rule in mathematics, and the rule is called associative property. And basically what that means is that three numbers will always kind of go together, okay? So like for example, 3 plus 2 equals 5. We'll say the three numbers that we're going to talk about here is 3, 2, and 5. Okay, they always go together in an associative property. So basically what that means is we can mix up these numbers in about 4 different ways, and they will always go together. So for example, 3 plus 2 equals 5. I could switch 3 and 2, and I could say 2 plus 3. Well, that also still equals 5, right? And then I could even make it into a subtraction problem. I could take 5 minus, and I could either plug in 3 or 2. So let's plug in 3. 5 minus 3 equals 2. And then I could do it one more time. I could say 5 minus 2 equals 3. Okay, so this is the associative property. These three numbers always go together. Now these are really small numbers, and today what we're going to be using is we're going to be using kind of big numbers like 18, 23, 46, and these are a little bit more difficult to figure out. So what the directions say today is trade ones for tens and solve the addition problems. Check the correct sum.
So that's what I'm going to do today is we're going to go through this and we're going to regroup. And regroup basically means that you're taking the same numbers that are in the associative property, but you're changing the way that you're looking at them, or you're grouping them in a different way. So for example, our first one here says 18 plus 8. And I'm going to draw out what all of these numbers are over to the side. Now, you remember that this long stick equals what? It equals 10, right? It represents tens, and then these individual units equals ones, okay? So what they've done to make this easy for you is they've drawn out our long stick that is 10 ones, and then we've got, and I'm just going to put dots here to make this fast, but we've got 1, 2, 3, 4, 5, 6, 7, 8, plus, and then we've got how many over here? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put this over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 18 because we've got the 10. So 10 plus 8 is 18. And then we've got the ones over here, which is 8. So this is this equation. 18 plus 8. And we're trying to solve for the answer. Now we can count up every little thing here, or we can regroup. And regroup makes our eyes, it kind of tricks our eyes into seeing it in an easier way. So what we're going to do with this is we are going to just find 10 of all of these ones, and we're going to squish them together, and we're going to take away the ones, and we're going to make a new group of 10. So I want you to count with me 10 units. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to stop right here. I'm going to take all of those units, which I know now equals 10, and I'm going to make this. I'm going to make a new 10. So I've got one 10 here, and now I've just made a new 10 with all of these units of 1, and then I'm just going to add that to whatever is left over here. So this equals what? 1, 2, 3, 4, 5, 6. It equals 6. 1, 2, 3, 4, 5, 6. 6 units. So now we've got 20. This is 2 units of 10 plus 6. So 20 plus 6 equals what? Well, that's pretty easy. It's 26, right? So let's see if that is the correct answer to 18 plus 8, okay? And if we're right, then that 26 would be part of that additive property as well. So 18 plus 8, we think, equals 26. So let's plug this in. And let's just count it up. Let's count the individual ones that we've got here. So we've got 18. We're going to count on 18, 19, 20, 21, 22, 23, 24, 25, 26. So we've got it. Here is our group of numbers, our 3 numbers that always go together. But we regrouped them in a way that our eyes could see that was a lot easier when we have just the tens to count up instead of each individual unit. So that's what we're going to do for the rest of our problem. So the answer down here, 18 plus 8 is 26. So I'm going to put a check right here. Okay, let's go on to the next one. The next one is 23 plus 19. And let's draw out what they've got. They've got 2 units over here of 10s, and they've got them laying on their side, but I'm going to make mine standing up. And then they've got 1, 2, 3 units of 1 plus, and they've got 1 stick right here of 10, or a column of 10, and then over here they have 9 individual units. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then we're going to add them up together. So we've got 10s and 10s and 10s here. So we've got 3 10s, and that's pretty easy to see. But we want to take all of these individual units and turn them into another 10 so that we don't have to count them all up. So we know how many is over here. Well, it's 19, so there's 9 units. So 9 plus 1, we could take one of these over here, bring it over here, and then this whole thing we could change just into a 10. So instead of counting all of these units, all of these individual units, we would change this just into one 10. So now we've got 1, 2, 3, 4, okay, 10s. And how many ones do we have? Let's count up our ones. 1, 2. So we've got 2 ones, okay, which gives us the number 42. So we're going to come over here and we're going to put a check next to 42. That was pretty easy, wasn't it? Instead of counting up all of those individual ones, we just took all of the ones, squished them together, made them into a column of 10, okay? Let's go on to the next one. The next one is 7 plus 46, okay? 7 plus 46. And I'm going to draw this out. 1, 2, 3, 4, 5, 6, 7. We've got 46, which means 1, 2, 3, 4 columns of 10, and then we've got 6. 1, 2, 3, 4, 5, 6. So what I'm going to do is I'm going to take 7, okay? And then I need to count to 10. 7, 8, 9, 10. So I'm going to circle these, okay? And then I'm actually not going to use these anymore. I'm just going to make a new column of 10 because we know that 7 plus 3 is 10. And then we're going to see how many we have left. So now, how many of these do we have? We have 1, 2, 3, 4, 5 tens, okay? And how many units of 1 do we have? We have 1, 2, 3. So our answer is going to be 53. 53, there it is. See how easy that was when we regroup and we count them? Because we know that there's 3 numbers that go together in an additive property, but it's hard for us to see that sometimes and have to count all of these individual units. So we regroup to make it easier so that we can just quickly see all of those tens in these columns. So that's much easier, and that's a lot of fun. I enjoyed that a great deal. So I will see you guys again next time. Bye-bye.
All right, welcome back. It's nice to see you again. What we're going to do today is we are going to be comparing numbers, and we've got a Thanksgiving themed worksheet. This is going to be lots of fun. The directions say, help the turkey find the way out. Draw a line to connect all the numbers that are less than 57. Less than 57. Okay, so let's think about this. Let's come over here to the side and let's draw out a number line, okay? And in the middle of my number line, I'm going to put 57 like this, okay? What would be a number that would be the next number up from 57 that would be greater than 57? What would that be? That would be 57, 58, 59, okay? 60, those would all be examples of numbers that are greater than, right? But we're looking for numbers that are less than, so we need any number below 57, like for example, 56, 55, 54, 53, and all the way down to 0, right? And all the numbers that are in between that. So we're looking for all the numbers on this side of the number line that are less than 57, okay? So let's think for a minute about where we're gonna go. Let's start at the turkey, okay? And he's trying to find his way out. So let's come on out, okay? And let's see which direction to go. Now, do we go to the 18 or the 77? Is 77 less than 57? No, it's greater than 57. It's bigger than 57. So let's look at this one. What about 18? Is that less than 57? Yeah, so we're going to go down to this one right here. It would be 18 would be on this side of the number line, okay? So let's go on down and let's look. The next direction we can go is either 99 or 21. Which one is less than 57? 99? Nope, that's too big. 21? Yep, that's smaller than 57. So we're going to go around this way. Okay, that's less than 57. Now we can either go to 58 or to 3. Which one is less than 57? Don't get confused here. 3 is less than 57. 58 is on this side of the number line. You remember, we don't want to go that way, so we're going to go up to 3. Okay, and then we're going to come through here and right through here, and then we've got a couple of choices. We can either go to 60 or 56. Which one is going to be less than 57? 56 is less than 57. It's even on our number line that we drew. 60 is more than or greater than, so we're going to go to 56, okay? And then let's keep going around here. We can either go to 10 or 67. So 10 is less than, so we're going to go this way. And then we're going to keep going around. You're doing so good. And then we've got two more choices. We've got 57 or 31. Now this one's a little bit tricky. I didn't talk about this. We're looking for numbers that are less than 57. Is 57 less than 57? No. It's actually equals to. That means the same as. So that's not where we need to go. We need to go less than this way. So our other choice here is 31. 31 would be on this side of the number line. So we're going to go to 31. And look at that. We made our way out. We got our turkey out of our maze, didn't we? Great job today. Bye-bye.
Hello, boys and girls. It's Teacher Mike here. And today we're going to be looking at some word problems. We're going to read the directions really carefully, read the word problems even more carefully. Let's get started right away. Birthday word problems. Read each word problem. Circle the correct operation, plus or minus, to complete the equation. Then, add or subtract the numbers and circle the correct total. So in this worksheet, we're going to have to read the problems really carefully. Figure out whether the problem is asking us to add or subtract, and then solve the problem. Let's get started right away. Matt is really excited for his 7th birthday party. Matt is hanging balloons around. He has 5 blue balloons and 6 purple balloons. How many balloons does he have in total? Whenever I see a word problem, I like to read the whole thing first. Then I'm going to go back and reread the problem and underline the important information. Let's go back and reread and underline the important information. Matt is hanging balloons around. That's cool, but not so important for our problem. He has 5 blue balloons. That's some important information. Let's make sure to underline that. And 6 purple balloons. Another piece of important information that we should underline. How many balloons does he have in total? In total. There's my clue word. I think we're going to have to figure out how many blue balloons and purple balloons we have together. So let's draw my blue balloons. I know that there are 5 blue balloons. I also know that there are 6 purple balloons. So now that I have my drawing of my purple and blue balloons, I have to really think deeply. If I have 5 blue balloons and 6 purple balloons, and we want to know the total, do you think we're going to be putting these balloons together and adding them up, or taking some balloons away? In this problem, nowhere does it say that a kid popped a balloon or a kid took a balloon home. Nowhere the number of balloons is getting smaller. If anything, the number of balloons is going to get larger because we have to find the blue balloons and the purple balloons added together. We're going to be adding in this problem to find out the total. The word total usually gives you a clue that this is an addition problem. So let's count our balloons or add them together. I know we have 5 in the top row, 1, 2, 3, 4, 5, but let's keep counting to find out the total. 6, 7, 8, 9, 10, 11. Okay, I think there's 11 balloons, but let's just write 5 plus 6 and check one more time. Choose the strategy of counting on. 5, 6, 7, 8, 9, 10, 11. 5 plus 6 is 11, so this problem asks us to add the balloons, and it gives us a total of 11 balloons, both blue and purple. Let's read the next problem just as carefully and see if it wants us to add or subtract. At the very same birthday party, Matt and his friend ate pizza for dinner. There were 12 pizzas. The children ate 7 of them. How many pizzas were left over? Okay, good. We read the whole problem. But now let's back up and reread the problem and underline the important information. Of course, we'll draw the pizzas. Unfortunately, we can't eat the pizzas. Matt and his friends ate pizza for dinner. Sounds tasty, but not that important to our problem. There were 12 pizzas. That sounds like a fact. There were 12 pizzas there. Doesn't sound like we're getting any more pizzas, but let's keep reading. The children ate 7 of them. Another piece of important information. When you eat pizza, does the pizza disappear, or do you get an extra pizza? When I eat pizza, it usually disappears into my stomach. That's like taking pizza away, which is just like subtracting. But let's keep reading before we make that decision. How many pizzas were left over? So it seems like it wants to know how many pizzas were left after the kids ate 7. Now, if you ate 7, are we adding or subtracting? Well, let's draw our 12 pizzas. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pizzas. Now, I ate 7 pizzas. Like I said before, those pizzas are disappearing, or we're taking them away, or we are subtracting those pizzas. So let's cross out the 7 pizzas that the kids ate to find out the answer. 1, 2, 3, 4, 5, 6, and 7. So how many pizzas are left over? 1, 2, 3, 4, 5 pizzas left over. So I think the answer is 5. 12 minus 7 equals 5. But let's write that, 12 minus 7, and use our strategy of counting back to see if 12 minus 7 really equals 5. 12, remember, don't count 12, 11, 10, 9, 8, 7. I have 5 fingers up. 12 minus 7 is 5. Boys and girls, remember, when you have a word problem and you have to figure out whether it's an addition or subtraction problem, look for clues like total or left over, and then draw pictures to help you imagine the problem and figure out the answer. Great job, boys and girls. We'll see you next time. Hello, boys and girls. It's Teacher Mike here, and today we're going to be working on a fun subtraction worksheet. I'd like to go over a strategy I called counting back to make this worksheet a little bit easier. Let's review this strategy, and then we'll try the worksheet together. For my strategy, we're going to be counting backwards. So for a problem like 7 minus 3, we're going to say the number 7 out loud. I like to touch my chin when I say the number to know that I'm not counting it in my subtraction problem. So let's try it together. 7 minus 3. We're going to say the number 7 out loud, 7, and then we'll count backwards till we get to 3. We'll use our fingers to help us keep track of how many times we're counting, and however many fingers we're holding up, well, that'll be the correct answer. Let's try it together. 7, 6, 5, 4, 3. Okay, I landed on my number 3. How many fingers am I holding up? 1, 2, 3, 4. So 7 minus 3 equals 4. Let's use this strategy of counting back to answer these questions on this worksheet. Let's read the directions and get started right away. Subtract with the little penguin. Help the little penguin find his path to his mother. Draw a line to connect all the ice flows where the number 6 is the total. Okay, I think we should start where it says start. So our first problem is 13 minus 7. Let's use our counting back strategy again. 13, remember, don't count 13. 13, 12, 11, 10, 9, 8, 7. Okay, I landed on my target number of 7. Am I holding up 6 fingers? 1, 2, 3, 4, 5, 6. I am. So this is a great place to start. Where are we going to move from here? I say we try all the numbers that are connected to this to see if 6 is the total. If it is, we'll draw a line. And if it's not, we'll know we have to try something else. So let's try 10 minus 4. Counting backwards again. 10, 9, 8, 7, 6, 5, 4. Do I have up 6 fingers? Yes, I do. So let's draw a line from 13 minus 7 to 10 minus 4. Good start. So now from 10 minus 4, I have 2 choices. I can draw a line to 12 minus 6, or I can draw a line to 16 minus 8. Let's try 12 minus 6 first. 12, 11, 10, 9, 8, 7, 6. I landed on 6, and I have 6 fingers up. Counting backwards is a good strategy to make the subtraction go a lot faster. So let's draw a line from 10 minus 4 to 12 minus 6. Again, I have 2 choices. I can draw a line to 16 minus 10 or 17 minus 5. Let's try 17 minus 5 since we're working horizontally. 17, 16, 15, 14, 13, 12, 11, 10, 9. Already I see that I have way more than 6 fingers up. I don't think that 17 minus 5 is the right answer. Let's try 16 minus 10. 16, 15, 14, 13, 12, 11, 10. 6 fingers up. This must be the correct answer. Let's draw a line to 16 minus 10. Now for this problem, I have 3 different choices. I can draw a line to 16 minus 8, but I already know that's not the right answer because I tried that for another problem. So I'm left with 12 minus 4 or 19 minus 13. Let's try 19 minus 13. 19, 18, 17, 16, 15, 14, 13. Does 19 minus 13 equal 6? I think so. I have 6 fingers up. Let's draw a line to 19 minus 13. Another place where I have 3 choices. I can draw a line to 11 minus 5, a line to 14 minus 7, or a line to 16 minus 9. Which one do you think is going to be equal to 6? Well, I know 16 minus 9 probably isn't the right answer. It's going to have too big of a difference. What about 11 minus 5? Let's try that one. 11, 10, 9, 8, 7, 6, 5. Okay, I got to 5 and I have 6 fingers up. 11 minus 5 is definitely 6. So let's draw a line to 11 minus 5. Again, I have quite a few choices here. Can you do 13 minus 3 in your head? Because if you can, you would know that 13 minus 3 is just 10. Because 3 minus 3 is 0. So I don't think 13 minus 3 is the right answer. Let's try 17 minus 11. Counting backwards again. This is a skill that really tests your number fluency to see if you can count backwards really well. 17, 16, 15, 14, 13, 12, 11. 6 fingers up. 17 minus 11 is 6. Nice job. So again, we have a few choices. We can draw a line to 14 minus 9, or we could draw a line to 16 minus 9, or we could draw a line to 15 minus 9. Which one do you think is going to equal 6? Well, I think 14 minus 9, well, that's not going to be enough. Those numbers are too close together. 16 minus 9, we already know those two numbers are too far away. So let's try 15 minus 9. Let's count backwards from 15 to 9. 15, 14, 13, 12, 11, 10, 9. 6 fingers again. Excellent job. Let's draw a line to 15 minus 9 because 15 minus 9 equals 6. Now there's only one more place to draw a line to, so let's check our work just to be sure. Let's count backwards from 14 to 8. 14, 13, 12, 11, 10, 9, 8. 6 fingers. We've now drawn a line to all the subtraction questions that have a difference of 6. Great job using the counting back strategy, boys and girls. Remember when you're subtracting, for example, like 7 minus 3 in our example, say the number, but don't count it. Touch your chin just to make sure. 7. And then count backwards to the other number, using your fingers to help. 7, 6, 5, 4, 3. Count the fingers. 1, 2, 3, 4. 7 minus 3 is 4. Great job, boys and girls, using the counting back strategy with the penguin. We'll see you next time.
When we count past 100 to 120, we can follow the same pattern that we used when counting from 0 to 20. You can even start counting at any number as long as you remember the pattern from 0 to 20. Let's count from 7 to 20. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now, let's try counting from 107 to 120. We can use the same pattern we just used to count from 7 to 20. 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, and 120. Can you see the relationship between counting from 0 to 20 and counting from 100 to 120? It's quite similar. They follow the same exact pattern. This can help us count up starting at any number. Let's try it again. Let's count from 109 to 120. We can follow the same pattern from when we count from 9 to 20. First, let's count from 9 to 20 to figure out the pattern. Then we'll use that pattern to count from 109 to 120. Let's get started. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now let's try 109 to 120. 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, and 120. Great work! Now it's your turn. I'll leave you with a challenge. I want you to count from 104 to 120. You can use the pattern of counting from 4 to 20 to help. I'll give you some time to think, but if you need more time, you can pause the video and answer when you're ready. Okay, here's the answer. Let's count from 104 to 120. We can follow the same pattern from when we count from 4 to 20. First, let's count from 4 to 20 to find out the pattern. Then we'll use that pattern to count from 104 to 120. Let's get started. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, and 120. Remember, you can use patterns to help you count starting at any number. Thanks for watching, boys and girls. We'll see you next time.
Subscribe to our channel to stay updated on new videos. Find links to our apps in the comments below.